Did you know that the James Webb Space Telescope is a space-based observatory named after James E. Webb, who served as NASA's second administrator? Yes, the Apollo missions under Webb's direction were the ones that brought the first people to the moon. But he also started a rigorous space scientific program that during his administration led to more than 75 launches, including the first interplanetary explorers for the United States. We can observe some light spectrums with space-based telescopes that are blocked by the Earth's atmosphere. Both the ultraviolet or UV and the visible portions of the electromagnetic spectrum can be used by the Hubble Space Telescope, which has been built and optimized for both. It takes time for all of the light you see to reach your eyes, including the illumination from your desk lamp a few feet away and the distant twinkle of stars. Fortunately, light travels at a breakneck speed. The Hubble Space Telescope's discoveries will be supported and expanded upon by the James Webb Space Telescope, often known as Webb or JWST. This gigantic space-based telescope is tailored for infrared wavelengths. Webb was launched on December 25, 2021. The James Webb Space Telescope or JWST made history on July 12 when it unveiled its first image, a gem-filled image dubbed the deepest photo of the universe ever taken. The James Webb Space Telescope not only has a wider field of view than any observatory before it, but it also has the following secret up its mirrors. It has the ability to observe faraway stars and galaxies when they first appeared 13.5 billion years ago, not soon after the start of the universe as we know it, looking further into the past than any other telescope. How is that even possible? How is it that a machine could travel back in time? It's not magic, it's just the nature of light. The JWST was built to operate with a variety of infrared wavelengths, and this is a significant factor in why the JWST can go further into the past than Hubble. Telescopes can be time machines. Looking out in space is like looking back in time. NASA scientists explained on webtelescope.org. It may sound fantastic, but the process is actually quite straightforward. Light requires time to travel through immense stretches of space and reach us. It will have much greater sensitivity and cover a wide range of light wavelengths than Hubble. Longer wavelengths allow JWST to glimpse the first galaxies that emerged in the early cosmos and to gaze inside dust clouds where stars and planetary systems are developing right now. The time in the evolution of our universe when galaxies first started to form has not yet been observed. We still don't fully know how supermassive black holes formed in the center of galaxies, and we don't know if the black holes came into existence first or if the galaxies did. However, Webb will be able to look into dust clouds with high detail, where neighboring stars and planets are forming. The number of planetary systems that might support life is unknown, but Webb could determine whether some Earth-like planets have enough water to support oceans. We don't know a lot about dark matter or dark energy, but we want to find out more about their current locations, as well as the timeline of the universe's expansion that we attribute to dark energy. Then there are the surprises that we cannot foresee. You won't even notice it moving at kilometers per hour. The majority of objects in the night sky are billions of miles away, so when you look at them, you're witnessing light that has come a very long way to reach you. Consider the sun as an example. The distance between Earth and its star is typically 150 million kilometers. Accordingly, the time it takes for light to reach Earth from the sun is 8 minutes and 20 seconds. Therefore, even though it never is a good idea to look directly at the sun, when you look at it, you're actually seeing it more than 8 minutes ago rather than right now. Or in other words, you're looking 8 minutes into the past. Since the speed of light is important in astronomy, scientists prefer to measure vast distances in space in light years rather than miles or kilometers. Light can cover approximately 5.88 trillion miles or 9.46 trillion kilometers in a year, or 1 light year. For instance, Polaris, the North Star, is about 323 light-years away from Earth. Whenever you see the star, you're seeing light that's more than 300 years old. Therefore, you can travel through time without even using a fancy telescope. All you need are your own unaided eyes. However, astronomers require telescopes like JWST to look truly far into the past, such as to the beginning of the universe. JWST can detect light at wavelengths that are invisible to the human eye, such as infrared waves, in addition to focusing on distant galaxies to observe visible light from millions of light-years away. Humans and other animals emit heat in the form of infrared energy. The naked eye cannot see this energy. However, infrared waves can reveal some of the universe's most elusive objects when viewed with the right equipment. According to NASA, infrared radiation can pass through dense, dusty areas of space without being scattered or absorbed because it has a much longer wavelength than visible light. Many galaxies and stars release thermal energy that can be detected as infrared radiation even though they are too far away, dim, or veiled to be seen as visible light. This is one of JWST's handiest tricks. The telescope can observe the light that was produced more than 13 billion years ago by the universe's oldest stars and galaxies. By using infrared sensing equipment, JWST used this technique to capture its iconic deep field image, and it will aim to use the same technique to gaze even further back in time, to the first few 100 million years following the Big Bang. Although the stars that the telescope will expose are truly long dead at the moment, JWST provides our mortal eyes with a unique time travel exhibition as their ancient light travels across the vast expanse of the universe. Studying the development of galaxies, stars, and planets in the universe is one of Webb's main objectives. We must peer far into space to look back in time, to observe the very earliest stars and galaxies that originated in the early universe. And because it takes light, time to travel from there to here, the further we look back in time. Due to the expansion of the universe, objects are moving away from us faster as we gaze more and further away, which causes the light to redshift. Redshift is the term used to describe how light that is initially released as ultraviolet or visible light is gradually shifted to redder wavelengths, eventually reaching the near and mid-infrared region of the electromagnetic spectrum for very high redshifts. Therefore, we must see infrared light and use a telescope and tools designed for this light to research the earliest star and galaxy formation in the universe. In the local universe, star and planet formation take place in the centers of dense dusty clouds that are invisible to human eyes at typically visible wavelengths. Due to its greater wavelength and less interference from the tiny dust particles, near-infrared light can pass through the dust clouds. We can see through the dust and the produced near-infrared light to the mechanisms of star and planet formation. Mid-infrared wavelengths are where objects with temperatures similar to Earth's most often produce radiation. Mid-infrared radiations allow us to glimpse the light of star and planet formation since these temperatures are also present in dusty areas where stars and planets are forming. With the aid of an infrared-optimized telescope, we can see through dust clouds to the star and planet-forming regions. Alright guys, that wraps up our video for today. If you enjoyed watching and you found it useful, please give us a thumbs up and hit the subscribe button for more.